let me give you the, okay, let me give you the sample. The sample here. Okay. Structural equation modeling, metric. Okay, hold on. I'm going to show you the, okay, here. Okay, can you see on the screen?
Yes.
Can you see on the screen?
I just see the same drawing.
Okay.
Yeah, we can
Let
see
me
the
share
screen,
again.
Prof. We can see the.
Okay. All right. So this is the sample of mediation and moderation variables. So let's say we are eating food, right? We're eating food, and then we full, right? The consequence is we will full of stomach, and after that, after we full of stomach, we will feel sleepy, right?
Yes.
We will feel sleepy. So it means that the full here, it means the mediation, because there is no relationship between eating and sleeping, right?
Yes.
Eating cannot influence sleeping, but eating have to go to a full first, full of stomachs first, and after that, it will make you sleepy, right?
Yes.
So that's the sample of the mediation variables. This one also, the mediation variables, the social support. If we have the support from our friends, from our family, from our college, so we will have the intention to do something, right? Intention to do, like to make the business, to open the business, right? And after we already have the intention to open the business, so it will become our behavior. So this our behavior, our tradition or our behavior to do everyday lives, right? So this is the intention will become the mediation variables. So we will try in this case in AMOS analysis how to describe and how to analyze the mediating variables, and what is the result and how to interpret the results. So we will try now using AMOS. Okay.
Okay. Thank you.
Okay. Okay. And also the one on the another one is when we have the compensation, and then we will satisfy with our job, and when we satisfy with our job, so we're not going to leave in from this organization. So intention to leave will be low, right? So this is the connection, how how the compensation can influence the intention to leave. So the intention to leave, but through the job satisfaction. If they don't satisfy with their job, so the intention to leave will become bigger and bigger. Okay. All right. So we continue. There is the question in the chat box. Can you explain about the error terms? Can you explain about the error terms? Okay. I think I already explained before. The error terms. The error terms, like the one here, I will show you the screen again. Where is our, okay, here. Okay, the one here, the error terms, what does it mean? It means that the error cannot be observed in this indicator. There is something is missing there in the observation, in our observation. When we do the questionnaire, when we distribute the questionnaire, there must be something missing in your research. I mean that all of your questionnaire is not perfect. There must be something missing in the phenomena that cannot be explained. So that's the reason us as the researchers have to figure out more and more to know, to better understanding what is the error inside the phenomena. So I hope you understand my explanation about the error terms. Okay, and okay, this is already explained.
Okay, when the error equal to 0?
Sorry, what you said?
When the error equal to 0.
When to the error equal to 0? I'm not sure what you explain. Maybe there is some explanation behind that. All I know is that the error term is something hidden in the phenomena. So if the error term is equal to 0, I cannot explain too far because I only know until this stage. I'm not sure how to make the error terms equal to 0. I hope this makes sense, right?
Yeah. Thank you, Professor.
Okay. And then another question is, as we haven't taken all the variables or factors, that is why we need these error terms to make. As we haven't taken all the variables or factors, that's why we need these error terms to make it. So okay, let me explain. Let me explain. The error terms, we need the error terms if we still believe that there is something missing in our research. There is something missing in the field. It's not observable. We cannot observe too deep. So we will put the error terms here to know this is the phenomena should be figured out in depth in the future research. Okay, so this is the one. All right. Another question is, what is the difference between AMOS and PLS regarding analysis? Yes, there must be a big difference between AMOS analysis and PLS analysis. The AMOS analysis, if we have the big data, which is more than 200, 300 observation, 300 questionnaire, 300 respondent, 300 respondent. So it would be better if we use AMOS software. But if we have the small sample, if we have small sample, so we can use the PLS. If we have more below than 100 respondent or 100 samples, just use PLS also fine. This the first. And the second is, if the our data is not good, it's not distributed normally, not normally distributed. So we can use the PLS. But if we have the good data, the high quality data, and have normality, meet the normality assumption, so just use AMOS analysis. AMOS is to confirm. AMOS is to confirm the theory, but PLS is aims to predict the theory. So that's the main difference between AMOS and PLS. And also, AMOS is the parametric test, right? Using the parametric statistic, and PLS using the non-parametric statistic. The non-parametric statistic is the data is not normally distributed, so we can use the non-parametric statistic using PLS. Okay, I think more or less like that, the difference between AMOS and PLS. Okay, so in this case, we will use the AMOS analysis. We will use the AMOS analysis to describe and to interpret the finding. Okay, I hope we already reached this stage. We already reached this stage. Okay, so we'll continue again the analysis. So now the question is how to analyze this model. Okay, so I will try to analyze this model, but firstly we have to save it. We have to save first the one here. After we build the model, after we finish the model, we save, right? We save it. I will save in here. I will save HBAT practice, right? Practice. Okay, HBAT practice in here, the desktop. Once you save it, after you save it, and then you can calculate using the icon here. Calculate and calculate. Okay. After you calculate it, the process and the arrow will be like this. The arrow will be like this, and then click this arrow, right? Okay. Click. Okay. So now the figure, the number, the result come up, and now it's time to describe. It's time to interpret what is all about. What does it means, right? Okay, what does it means? So I will explain the data one by one. First of all, before this, we have to set up what is the result we need in here. First, we have to click this one, the analysis properties, the one here, the icon here. So in here, you will find the output. So which output you expect to come up, to appear in the model? So I would choose the standardized estimate. I will choose the indirect effect. Okay, the one here for the mediation analysis. So you have to check this box if you want to analyze the mediation analysis. Okay. Okay. And this one for the R-square, this one for the fixing the model. If the model is not good, we can fix using this one. Okay, maybe we can just check all the boxes. Checks all boxes. One, choose all the boxes, and also this also we check. Okay, I think it's enough, right? I think it's enough. Checks all the boxes. Check all the boxes in here. Okay, I will repeat again. In this icon here, just click and then go to output, and then make sure all the boxes is checked. All the boxes checked. Okay, hello. All the boxes is checked. Okay, after that we close it, and then we run again. We calculate again. We calculate again. So the finding will come up. The output will come up. Okay, using the one here, just click one times. Just click, and after that, go to here. Click here. Okay, and then don't forget to choose this standardized estimate, not unstandardized estimate. Just choose standardized estimate here. Okay. All right. So now we can see the result, right? We can see the result until here. So I will explain which one is good relationship which one is not a good relationship. Okay, so the one here, if we can see from these two head arrows here, so the outputs have 0.26, which is very low, below than 50, below than 0.50. So it means that each variables here, every variables in the exogenous variables is not disturbed to each other, right? So this one is not influence this one, on this one also not influence this one, and this one is not part of these variables, and this variable also is not part of these variables. It means no correlation. It means that this is already free of multicollinearity. So I will repeat again. This correlation is free from multicollinearity. Okay. All right. So I hope you understand what I'm saying. What the meaning of this two-head line here. So this line is having low figure, low number. It means which is good. So there is no multicollinearity between these variables. Okay. Okay, next. What is this? The number between the IV and V. We have 0.25 here. The 0.25. This is called as beta. This is called as beta analysis. This is beta. If you see in the SPSS analysis, you will find beta there in the regression analysis. So it's called as the beta analysis. What is beta means? What beta means? It means that the environmental perception, if the environmental perception is better 1% or better 1% higher, so it can increase the job satisfaction around 25%. Okay. 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 I will repeat again. If the environmental perception become better 1% or 1 point, yeah, 1% or 1 point, whatever, and it can increase the job satisfaction for up to 20% or 20 points. Okay, that's the meaning of beta here. That's the meaning of beta here. This is also the beta, this is also beta, this is also beta. Okay, so this for answering the hypothesis is does the environmental perception influence significantly on job satisfaction? Does attitude toward coworkers influence significantly toward organizational commitments? So we will see the answer later. So this is the answer actually. This one, the beta can answer the question of the analysis, and the one here, the indicator. We have also the number. We have also the number here. What is the number? What is the number? The number is loading factor. We usually call this the loading factor here. We usually call this the loading factor 0.96, right? 0.6 H. Yeah, 0.6 H. So according to the Horner-Laker 1980, if the loading factor is more than 0.6, so it will be acceptable. If the loading factor below than 0.6, it will be not acceptable. Okay. So I will repeat again. The loading factor here, 0.6 0.79.82 here. So it means that the EP1 can explain the environmental perception for 68%. The EP2 can explain the environmental perception for 80%. EP3 can explain the environmental perception for 79%, and etc. and etc. Okay, so the loading factor is the ability of the indicator, which can explain the variables. Okay. Okay, the question here, we have the question in the chat box. Does it mean the higher beta value, the better the relationship? Answer is yes. The higher the beta, the better is the relationship. So the hypothesis will be more supportive. Okay, so I hope you can understand. Yeah, until now, have you got any questions so far? Maybe we can have a picture now. We can have a picture. If you don't mind, can you just open your camera so we can just take a picture for a while, and
yeah.
after that.
Yeah. Can you open your camera? You can see.
Okay, thank you. Okay, thank you. All right.
Yeah, Dr. Amsal, you
Okay,
can
here,
take a picture.
47, right? 47. Okay, I believe someone from Pakistan, Bangladesh. All right. All right. Okay.
Yeah, I know many of them, my friend. For example,
I saw also my friend.
Yeah.
So from many different countries here.
Yeah, from long
Okay.
time.
Can you just open the camera? So I will screenshot here. Okay. Thank you very much. So 1, 2. Okay. 1, 2, 3. Okay. Again, the next slide. 1, 2, 3. Okay. Another. 1, 2, 3. Okay. Another slide. Okay. I think it's enough. Thank you for your kindness. Okay. I will share the 1, 2, 3. Okay, I will share the photo, maybe. Okay, there is someone from India, from Nepal, from Bangladesh, from Malaysia, from Vietnam. Thank you for coming. So we can study together here. So we will have a good sharing now together. So we'll continue on our lesson today. So we already reached this stage. Thank you. From Ghana, from Pakistan, from Nigeria, Bangladesh, Nepal, Vietnam. Okay, you are welcome. I really appreciate your from Ukraine. Okay, from Ukraine also here. Thank you very much. All right. Okay, from Philippines also here. Thank you very much. I hope you have the maximum learning now today. So we will share to you the recording. Dr. Mahadi Hassan will share the recording. Oh, from the Saudi Arabia also here. Nice. Okay, from Saudi Arabia also now. Okay, thank you very much. Okay, so let's continue our learning. So I will share again the screen. I will share again the screen. So now, how to describe and how to explain and how to interpret the data. Okay, if you already have this figure with you, you already have the output with you. Okay, and then you just click this icon here. By the time the what we call this, by the time the output come up like this, and click this text. Yeah, click this text. Okay, click this text. Okay, the menu come up. Okay, the menu will come up. Okay. Okay, I hope you can see on the screen. This menu will come up, and then make sure you click estimate. Make sure you click estimate. Okay, you click estimate, click. Okay, here we go. You already see which one is not significant, which one is significant, which one is not, which one is significant. As we can see, as we know that below than 0.5 is significant, right? Below than 6.5 is significant, but below than, more than 6.5 is not significant, right? So in here, if you can see the result here, the EP, the environmental perception to the job satisfaction, the environmental perception does influence significantly on job satisfaction. The answer is okay. Okay, the answer is here. Okay, the answer is here. The p-value is the p-value is 0.000 here. The star represents the 0, right? 0.000 here. Okay, and 0.852 is equal to 0.852. It means it's not equal. I mean the meaning of this is not significant. It's not significant. The environmental perception influence significantly on the job satisfaction here, because the p-value is 0.00, below than 0.0, which is below than 0.5, right? 0.05, I mean. So we can say as the environmental perception influence significantly on job satisfaction. The same like this one also. AC, attitude toward coworkers, does not influence significantly on job satisfaction because the number is more than the cutoff value of 0.05. Okay, so this is the answer. Which one is significant? Which one is not significant? This one also here, the attitude toward coworkers influence significantly on the organizational commitment, like this one here. So the result is significant, is supported, right? It's supported. So the one here, the job satisfaction toward the organizational commitment is not significant or is not supported because the figure is more than 0.05. Okay, I hope it makes sense. I hope you can understand. Okay, there is the question in the chat box. Okay, please repeat EP1 environmental perception value 0.68. What does it mean? So I will repeat again. the EP1, the environmental perception value 0.68. What does it mean? I will back to the model. I will back to the model. The EP1 here. What is the meaning of this? What the meaning of this figure? What the meaning of this number? The meaning of this number is the ability of the indicator can describe, can explain the variables of the environmental perception. So the higher the figure is, the better the indicator can explain the variables. Okay. So I hope this makes sense. So if you have the loading factor below than 0.6, it means that it's not acceptable. And it means that the EP1 can successfully explain the variables of environmental perception. Okay, but if the loading factor have more than 0.6, it means the EP1 can explain the environmental perception well. Okay, I think it can make sense. Okay. What is the question? Another question. Okay. The question is another question. Sir, can we use SEM using AMOS if we have time series data and the number of observations are 120 monthly data of Islamic banking? The answer is it depends, right? It depends because AMOS is very suitable for the questionnaire-based data. But if you have the secondary data like this, the time series, the number of observation 120, you also can use. You have to make sure there is the theory that there is the theory that has the indicator who can explain the variables, because in AMOS we use the indicator, every single indicator, to describe the variables, right? I repeat again, in AMOS analysis we use the indicator to explain the variables. Okay, when you have the indicator with you and can successfully explain the variables based on the theory, so you can carry on, just go ahead using the secondary data, no problem. But if you don't have the theory explaining that the indicator, there is an indicator can successfully explain the variables, so you better use SPSS or Stata or any software. It's not AMOS. Okay, it's not AMOS. All right. So that's my answer. Okay, and very informative session. Thank you, doctor. Thank you also for your coming. Okay, alpha value, loading value is the same. Okay, there is the question here. Alpha value and the loading value is the same. Alpha means the alpha means the error, or the how to say in English, the mistake, right? The mistake, or the alpha. Alpha, we usually call this here as the Cronbach alpha, right? The Cronbach alpha, but loading factor is the figure which is inside the indicator, the loading factor like this. Okay. So alpha is quite different from the loading factor. Okay. Another question is, how we have to use reflective and formative indicators. So the question from Sadhana, Mishara, she said that how to know we have to use reflective and formative indicators. For AMOS analysis, especially for AMOS analysis, we never use formative analysis. We never use formative indicators. But in PLS, we use formative indicators because in AMOS, we only confirm the indicators can reflect the variables, right? The variables. So we always use the reflective here in AMOS, never formative in AMOS. Okay. Okay. Another question is, can we use 2 or 3 indicators to measure any variables? Can we use 2 or 3 indicators? Yes, exactly. Of course, we can use at least two indicators. If you can analyze the variables, at least 2 indicators.
Prof, one thing.
Okay.
Can I please?
Yes, yeah.
From your model, it is pretty much clear that there are 2 independent variables and maybe there are several dependent variables, right?
Yes.
Job satisfaction, staying intention, organizational commitment, right? Am I right?
Correct. Correct.
Okay. So it is clear that maybe independent variable may be in less number sometimes, and dependent variable may be more than that also.
Okay. Yeah.
It is depending on the situation, yeah, and the relationship, right?
Yeah. It all depends. It all depends. The independent variables. Actually, this is not the independent variables like usual, like normal situation. This is actually the mediating variable here. The one here.
Yeah, that is good.
Variables, right?
Yeah.
So we will try to understand the mediation analysis using the job satisfaction and using the organizational commitment. We will try to explain later after this. Okay.
So in this structure, the mediating variable is in 2 ways, right? Job satisfaction or organizational commitment.
Yes. Yes.
Okay. Thank you, Prof. Thank you so much.
Okay. Okay. So we have 2 mediation variables here, and 2 independent variables, 2 mediation variables, and 1 dependent variables. Okay. Now we will try to interpret, to find the meaning behind this. Okay. Okay. I see here the question.
Doctor.
Okay. Yes.
I want to know that how can we be sure that the exact item is exactly the same which is being reflected in the data, because we cannot see the data, we just label them and we run the model.
Oh, I see. Okay. Okay, I will show you the raw data, right?
Yeah.
Because I will show you the raw data. Here is the raw data. I believe you already have it. I already.
Yeah. That we know. Yeah, it is okay. And you also uploaded the file at the first stage. You started with the file uploading in AMOS. I'm clear about that. But being a beginner, we may be like apprehensive that either we have like the right indicator is showing the right item. Maybe we can make the mistake. What is the solution for the beginners?
Okay. Oh, okay. Okay. So you means that
How to double check?
How to double check, right?
Yeah.
How to double check? So okay. I will show you how to double check. How to say? Last time I just typed this one, right? I just typed this one. EP1, EP2, EP3, right? EP1, yeah. EP2, EP3. As we can see here in the we also have EP1, EP2, and EP3 here. Where is the EP1? Here, right? EP1, EP2, EP3, and EP4. Okay, EP2, 3, and 4. And then how to cross check? How to double check? In here in AMOS, we just click this one here, the icon here. We click, and it will show you the right indicator, right? The right indicator. Okay, I hope you can see. Okay,
Yeah.
you can double check here.
Yeah.
So if you want to put again, you want to replace the indicator, also fine, no problem. For example, GS1, I put here, I replace here. GS2 I put also here. GS3 I put also here, and GS4 I put here. GS5 I put here. Fine, no problem. This is good to double check.
Thank you so much. Nicely answered.
Okay.
Thank you.
Okay, thank you. So this is clear already. So we will try to continue. So if you want to double check, just click this one, and then you put drag and drop one by one. It's not a problem. If you want to drag again one by one like this, OC1, OC2, OC3, and etc. Also fine, no problem. To cross check. And after you already finish all this analysis, and then we run the model. We will run the model using this one, the calculation. Okay, this calculation, and after you click, this arrow will be light, have a different color. Then click on it. Then you will find this figure. Right, in this figure is to analyze what's the interpretation behind this. Okay, to know that, to the few text here, the few text here. Okay, go to the few text, click, and then go to estimate. And then you will find here the, what we call this, the relationship. Which one is significant? Which one is not significant? So you can see from here the p-value here. Okay. Okay. I already explained before. Below then the cutoff value of 0.05, it means that the relationship between EP and GS is significant, but the cutoff value more than 0.05, it means that the AC not influence significantly, doesn't influence significantly on GS like this, more than 0.05. Okay, so I hope at this stage you're already clear, so we can continue on.
Prof, one thing. Can I please?
Okay.
Okay. So in smart PLS, yeah, we see that if the p value is more than more than 0.05, yeah, we are deducting, yeah. So we are deducting it. But in this case, in AMOS, what to do? Say, for example, when the value is coming more and we are deleting it, right?
Okay, yes, that's the same. The loading factor in PLS below than 0.5 is the factor loading. The factor loading which is below than 0.5, we have to eliminate, we have to omit it, right? And then we don't use that indicator
in our analysis or explanation. Yeah.
Yeah, but in here, the hypothesis between X and Y like that. The relationship significant or not significant. So the value explain the result like that. But the loading factor which is below than 0.5, we have to omit it, we have to throw, we have to eliminate it. This is the different case, right? Different case like this. I will show you the okay, I will show you the model. So here the model, this one is the loading factor like the PLS. PLS also have like this.
Yes,
Below
yes.
than 0.5, we have to throw the indicator. We cannot use it. But more than 0.5, we just keep it there. Okay? I hope you can understand.
Yeah, thank you, Prof.
Okay, and there is a question in chat box from IS, sir, regarding the mediator variables, what we advise about the approach, segment approach or causal approach? Okay, so for the mediator analysis, for the mediating analysis, we will use the causality approach. We will use the causality approach. So we will try to find which one is successfully mediate relationship, which one not successfully mediate the relationship here. Okay, so we will try. We will practice. And then another question is, can we use second order with AMOS analysis? Yes, the answer is yes. Of course, we can use the second order analysis using AMOS. But we use the first order analysis first before using the second order. Maybe in the different time, we can try to analyze the second order analysis. Okay, but if we have a time today, so we can use the second order analysis today. Okay. All right. Now we will find the question. How I mean, does the job satisfaction mediate the relationship between environmental perception and staying intention? That's the question. Does the organizational commitment fully mediate the relationship between attitude toward coworkers? And then question number 2 means that we will find the mediation analysis here. Does the job satisfaction mediate the relationship or not? And does the organizational commitment mediate the relationship between attitude toward coworkers and staying intention or not? So let's check here. So, to do this, just click here. Okay. And after that, go to estimate. Okay. Go to estimate. And then where is the matrix? I don't find here. Maybe okay. Okay, I don't find here. If you want to know the mediating analysis, we can use this one. Okay, just use this one. We have many ways. To analyze the mediation analysis, including this one. I will show you. Okay, I will show the Google. In the Google, we have the mediation calculation, so we can use that to analyze the mediation. Okay. Google, I hope you can see my screen, right? I hope you can see my screen here in Google. To do the mediation analysis, we can use the application name Sobel test by Daniel Soper here, by Daniel Soper. Okay. The Sobel test. When you type the Sobel test Daniel Soper, this will come up. And then just click on it, and we will use this for the mediation. Right? Okay. We'll use this for the mediation. Okay. This one. We will put the number here, the result of the AMOS, the output of the AMOS here one by one. And then after that, we calculate. After we calculate, we will see, oh, this one fully mediate the relationship. This one's not fully mediate the relationship. Okay. So I hope you understand what I'm saying. Because yeah, actually my English is not so good. I hope you can understand clearly. Okay, so we can continue again in this area. We already come to this stage. So the calculation, how to calculate? Firstly, we have to know what is A, what is B, what is standard error A and standard error B, right? If we can see from the output here, see, this is A. In the estimate, the EP and GS, this is, we can call as E, yeah, E. And this is SE, standard error here. So just put this number into the Sobel test, and then we will find the answer. Okay, we'll find the answer. Okay, now first, what we put. Okay, we will try to analyze this one first. Okay, we'll try to analyze this one first. Does job satisfaction fully mediate the relationship between environmental perception and staying intention? So that's the question number one. So now we have to see the environmental perception and job satisfaction. So we just imagine that this one is environmental perception, this one is job satisfaction. So how to get the number in here? Environmental perception and job satisfaction is 0.216. Okay, 0.216 is A. We just put here 0.216. Okay, if I'm not mistaken, 0.216. Okay, that's correct. And also SE, standard error E, 0.053. 0.053. Where is 0.0? In here. 0.053. Standard error A. Okay, so we already done with the relationship between the what do you call this? Environmental perception and job satisfaction. Now we continue on the job satisfaction to the staying intention. Okay, job satisfaction to staying intention. Job satisfaction to staying intention means B. Job satisfaction to staying intention. Okay. What is the number? Job GS. Where is GS? Where is GS? Here. Okay. GS to SI. GS to SI. What is the number? 0.085. Just put in the box 0.085. Okay. 0.085 is already B, right? B. 0.085. Job satisfaction to staying intention. Okay. So job satisfaction to staying intention. So here have 0.085. and put here 0.085. And the last one is standard error B. Where is the standard error B? GS to SI, standard error B is 0.036. Okay, 0.036. Okay, we put again 0.036 here. We put 0.036. Okay. Okay, now we can calculate. We already put all the figure, and then we calculate. Just click calculate, and then the result will come up. Okay, click. Okay, waiting, and then yes, this one. Okay, we already got the result now. The result is the Sobel test statistic describe the Sobel test statistics show that the number of 2.04. It means that if you have the cutoff value of 0, not the cutoff value of 0, but the cutoff value 1.96. Okay, I repeat again. The cutoff value 1.96. If you have the Sobel test statistic more than 1.96, it means there is the mediation. Okay, there is the mediation between the variables, between the relationship between IV and DV. If you have the Sobel test statistic more than 1.96. Okay, I hope you can understand. Okay. Okay, there is a question in the chat box from IS. Sir, can we use the result of Smart PLS to check out whether full mediation or partial mediation with Sobel test? Yes, the answer is yes. You can use also a Sobel test for PLS, but you already have actually in the PLS already have the T statistic there. This exactly the same with the Sobel test. So you don't need to spend your time too much, right, to analyze again using the Sobel test, because you already have it in the PLS. The name is the T statistic. If you can find the T statistic there in the output of the PLS, that's exactly the same with the Sobel test. Okay, I hope it makes sense. Okay. So the answer is there is the relationship. There is the mediation. There is mediation between job satisfaction and the staying intention. Oh, sorry. I'm sorry. There is the mediation. Job satisfaction successfully mediate the relationship between environmental perception and staying intention, because we have the T statistic more than 1.96. Okay, I hope it's already clear what I explained. But
Yes.
There is any other question? Any other question so far from the floor? Just ask some question and I will answer. I will be happy to answer the question. All right. I think I have to get my charging because my laptop going low batteries now. Okay, hold. I will back in 10 seconds. Wait. Okay, yeah, I'm back. Okay, I already charged my laptop. Okay, yeah, it's done. Okay, so any questions so far from the floor about the mediation analysis here? I hope it's already have a better understanding how to use AMOS analysis, right? And one
Yeah,
more
Prof.
thing. Okay, one more thing. I will show you what's the how to say. I will show you what's the advantage of AMOS compared to other software analysis, SEM analysis like PLS, EFUS, like that. So in here in AMOS, we have the goodness of fit formula here. Okay, goodness of fit formula used for if we want to know this model will be truly can describe the data, the phenomena in the field. So how to know? How to know if we just see the number here, right? So we will use the goodness of fit measure to know whether the data can successfully describe the phenomena in the field or not. Okay, so I will try to put here in the model. I already shared the. I already shared the PowerPoint. We have there the PowerPoint number 11. If you can see the goodness of fit formula, if you see there, okay, I hope you can see now. Yeah, you can see here. If you can see this, just copy and paste this to the model, and then we will see the number, right? We will see the number. I will copy, okay, I will copy and then put in the model. I will put in the model. How to put here? We cannot copy and paste directly. We cannot copy and paste directly. Okay, straight up, cannot. But we have to use this one, the title. Click the title, and after that, I'm going to put the formula. Okay, I'm going to put the goodness of fit formula here, the title, and then just click in any field. Just click here, click. Okay, click, and then you can paste in this box. Okay, you can paste it in this box. Just paste it and use right align. Okay, right align, and then click OK. Okay, now we already have the formula here, so ready to analyze. Okay, so what is this for? The question is, what is this for? So this is to know that whether our models is already can successfully
Significant or not.
describe in sorry. Okay.
Prof, goodness of fit, can it be measured also using PLS, SPSS?
No. We don't have in the PLS for this formula, only for AMOS only. This why
Okay.
AMOS is very good used for the high qualified data. If you have the good data, if you have data which is normally distributed, just use AMOS. Otherwise, if you don't have the normal data, you can use PLS, and you can use any software. But in AMOS, if you have a very good data, very high qualified data, so you can just use AMOS, because AMOS is to confirm the theory. PLS only to predict the theory, to develop the theory. Okay. Okay. Let's continue on. I will continue on this. What is this for? What is this for? This is for we will know whether the model can really describe the phenomena in the field. It means that whether the data we already propose in this model can really how to say suitable with the data in the field, right? So to figure out, I mean, to know the answer, just click this, the calculation. After you click the calculation, then click this, like before, okay? Like before, the one I saw you before, okay? Okay, now the figure come up, okay? The figure come up. What is this? What does it means? Okay, the question is, what does it mean? So we have here for the what we call this the measure, the goodness of fit, we have statistical measure and non-statistical measure, but I think I have to change this. This one is goodness of fit formula, GOF formula. Okay, should be GF formula, goodness of fit formula. Okay, so the goodness of fit formula consists of statistical measure and non-statistical measure. It means that the goodness of fit formula measured by statistical and non-statistical. So we have two measurements here, the statistical and non-statistical. Okay, the statistical measure like this. If the significance more than 0.05, which is very good. Okay, if you find the significance here, more than 0.05, it means your model is really can describe the phenomena in the field. Okay, I mean every indicator you propose in the model, it means those indicators can really describe the phenomena in the field. It's not different between in the model and in the field. There is not big difference, right? That's the meaning. If significance more than 0.05, and the chi-square should be small, not big. Okay, but in here we cannot meet the requirement here. We cannot meet the requirement. Why? We cannot meet the requirement because the significance is below than 0.05, so which is not good. And the chi-square is very big, more than 200. It's big. So it means we cannot meet the requirement. So what to do now? Because we don't meet the requirement. Okay. Because since we cannot meet the requirement, we go to the another measurement. You remember we have two measurement, the statistical measure and non-statistical measure. If we cannot, if the statistical measure doesn't meet the requirements, just go to the non-statistical measure. One of them meet the requirement, so you can go ahead your analysis. You can go ahead using this software. Okay. The second is the non-statistical measure is a GFI, goodness of fit index, CFI, comparative fit index, TLI, tracker Lewis index, RMCA, root mean square error of approximation. It means that if all of these more than 0.9, the model is acceptable. The model is really can describe. The model can really can describe the phenomena in the field. But if the GFI is more than below than 0.8 or 0.9, so it's not really can describe, but still acceptable. 0.8 something is still acceptable, but it's not perfect. It's not perfect. I say, okay. I would say it's not perfect, but if you can find the GFI, CFI, and TLI more than more than 0.9, this very perfect. Okay, so that I would say. And here the RMC, root mean square error of approximation. So it should be in the range of 0.03 until 0.08. Okay, I will repeat again. The RMC would be in the range of 0.03 until 0.08. Okay, 0.08. Okay, so if we see in the non-statistical measure, the output meet the requirement. Okay, the output meet the requirement. It means that we can do next analysis for this. All right. Okay, I hope you can understand my explanation so far. If you have any question, just anyone have any question, just ask me the question. I hope you already have a better understanding how to draw the model and how to interpret the data using the AMOS. Okay, break for 5 minutes. Okay. All right, so we can break for 5 minutes time, and then actually I have another I need to explain which is the last thing. Okay, which is the last thing. We will break for 5 minutes. Okay, we'll break for 5 minutes and we will continue again after prayer times. Okay. All right. Okay. I will break for 5 minutes and I will be back. And then I will explain after this the most important thing. The most important things how to describe the data using AMOS and how to fix the model if the model is not good, right? If the model doesn't meet the requirement, how to fix it. So I will continue after 5 minutes after the praying times. Okay. 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 I'm going to close my video and I will go for prayers in 5 minutes time. Okay. See you soon. Thank you.
Hello, can you hear me?
Yes.
Yeah, if you want to say anything, you can you can share. If anybody wants to talk anything, you can share.
Okay. Okay, ladies and gentlemen. All right. So we will try to continue again now. All right. There is a question from the participant. There is a question. It's going well. My question: when we have scale which is undimensional, it may have 7 construct. Then how we can join them while preparing the model in AMOS? It may have 7 construct. It have 7 construct. Yeah, I think there's no problem. You can have 7 construct, but for me, if you have more than 6 construct, the analysis will be quite complicated. Okay, the analysis will be quite complicated, and then you will find it difficult. You will find it difficult to fit the data. You will find it difficult to fit the data. The goodness of it will be it's quite difficult to fit the model. So I would suggest you to use the AMOS analysis using using not more than 6 variables, not more than 6 variables. So you can use the AMOS analysis. It's very well. It's not so complicated. Okay. All right. And so now I'm going to show you how to fix the model. How to fix the model if you don't have a good fit, right? If you don't have a good fit. Okay, now I will show you the screen. Okay, for example here, you don't have a good fit here. You don't have a good fit. It means that the chi-square remain high, the significance is not good, right? And also, just let's say it's not good. The one thing you have to fix is the loading factor, like the PLS. Like the PLS. When the PLS, the indicator every measurement in the loading factor in the indicator showing below than 0.5, yeah, so you have to throw it. You have to throw the indicator. You have to omit it. You have to
0.5, Prof.
Sorry?
0.5.
Sorry.
0.5.
No, I mean 0 0.5. I mean 0.5. Sorry. Okay, I will repeat again. When the loading factor below than 0.5, so you have to omit it. You have to throw the indicator. Okay. In PLS, but in AMOS, we have the higher requirement. Like if you have below than 0.6, the loading factor below than 0.6, so you have to throw in, just like the one here, here. Okay, if you can, as you can see from the screen here, the loading factor. Okay, I'm using this one. Okay, if you want to make it bigger, just use this one. See, just use this one, and then you find which one is having low figure. Okay, this one. Okay, this one having the low figure. So it means that if you eliminate this indicator, the formula will become better. The formula will become better, right? Okay, this one, the one here, I will try to delete. I will try to delete. Okay, I'll try to delete using this. Okay, just activate this one. Activate, click on it, put it on, and then click this one, because it shows a lower loading factor. Okay. Okay, we already eliminate one, and after that we calculate again. We calculate, and then click this arrow. Click this arrow, and then the figure, the output will come up. As you can see now, the chi-square reduce, but little bit, right? And the GFI, CFI, TLI also getting higher now, getting slightly higher now after I remove this indicator, right? Okay. And then if you want to make it more better, I mean, if you want to make it better, the result, you also can use the modification indices. Modification indices, you can see in here. The modification indices going, okay, I repeat again, go to view text, the icon here, and then go to modification indices. Okay, yes, here. If you can see which one is bigger, bigger E23 and E24. It should be in the same construct. It should be in the same construct. Cannot go across the construct. Okay. This is the error terms. This is the error terms. Have to inside the same construct. Okay. Let's see. 23 and I mean E23 and E24. Where is E23 and E24? We can see here. E23, where is the E23? Just see. Oh, E23 and E24. This is not this in the same construct. Okay, this across the construct. We cannot co-vary like this. We cannot co-vary like this because it appears in the different construct. Okay. Okay. And then we find again another output, E23, E17 and E18. E17 and E18. Does it stay in the same construct or not? So let's see. E18 and E17. E18 and E17. Where is the E18 and E17? The one here, E18 and E17. E18 and E17. Oh no, this not in the same construct. We cannot copy. We cannot copy like this. We cannot, because where is the E18 here? Here, E18, here in here. We cannot copy like this. Okay, we cannot. See, we cannot copy like this because it appears in different construct, so we cannot do like that. That's not acceptable. Okay, so if you can see which one is acceptable, which one is not acceptable, you can see on the screen. As you can see from the screen here, this one is acceptable, this one is unacceptable, this one unacceptable, and this one is unacceptable. So only this is acceptable. So the indicator in the same indicator, in the same construct, I mean. Okay. Okay. So you will see here, this is the latent variables and this is the observed variables. Like the indicator is the observed variables, and this is the latent variables. Okay, the latent variable is cannot be directly measured, but the observed variable can be measured directly, like in this model. This is the latent variables construct, and this is the observed variables like this. Okay, so you already know how to fix the model. First, we just throw the indicator which has the low loading factor, and the second is we fix in here. We fix in here in the modification indices. If we have the error terms in the same construct, in the same variables, we can cover it like this: E1 and E2 like this. Okay, E16 and E17 like this, like that. Okay, we can cover this as long as the indicator in the same construct like this. So we can cover this to fix this model, to fix the formula, the GOF formula. Once the GOF formula has been fixed and good looking, so it means that this model can really describe, can really explain the phenomena in the field. So the model in here, we propose the theory we propose in the model almost the same. What's happening in the field, right? The theory we propose in the model hello, okay, can really happen exactly the same in the field. All right. Okay. There is a question here in the chat box. Calculating estimate, Sobel test, finding GOF. Is all these are the path to reach SEM, or these are the step to all SEM? The Sobel test, yeah, this is the rule. You know, this is the rule how to find the good data. The GOF we use for finding the good data. We want to confirm whether the data really can explain. I mean, the model really can explain the phenomena in the field or not. Okay. Okay. All right. Finding GOF for analyzing. I mean, to describe the phenomena in the field, which is the same with the model that we propose in this AMOS, and the Sobel test used for the to analyze the mediation, So calculating estimate, the calculating estimate is to answer the hypothesis, whether the environmental perception influence job satisfaction or not, whether job satisfaction influence significantly towards staying intention or not. So we use the calculate estimate here. Okay. So we will finish in 10 minutes. Maybe if you have any other questions, so we can continue in the WhatsApp group. Okay. So I hope you have the better understanding about our discussion for today. And I wish you can open again your camera, please.
Yeah, we can go for discussion overview and introduce our participant, where they are from and what they are doing.
Yeah, it would be nice. It would
And
be great.
also, I would like to give a great thank our Professor Dr. Amsal, and thank you everybody for attending this workshop, and we'll love to see in the next workshop as well. Also, if you have any query you would like to share with us, and we'd love to listen you, we love to learn from you, and we love to receive your advice and so on. So you can on your camera.
Okay, please. Okay, we have two screens here, so I will snap first. 1, 2, 3. Okay. Okay, so all is activated. Please open the screen. 1, 2, 3. Okay. Wait. Okay, wait. I will share to the group. Okay, I will share to the group. Okay, one and another one, please. Another one. Please open the screen, please. I will. Okay.
Maybe some of our friends, they feel shy to open the camera. Is it?
Okay, maybe they're away from. Okay, 1, 2. I will share to the WhatsApp group. 3. Okay. 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 I send it the group again. Another one. Go here. 1, 2. Please open the screen, please. 1, 2, 3. Okay. I share again in the WhatsApp group. All right. Okay. Okay. One more. Okay. 1, 2, 3. All right. Okay. I already sent in the WhatsApp group. Thank you very much.
So
okay, if you do
anything you would like to
yes,
say, our participant? Anybody else? Here, Associate Prof, maybe Aida Mukhtar from Malaysia. And also I can see the Fitri, Dr. Fitri. Where is she?
Nice.
So there is a...
I would like to say thank you, Doctor. It's really a privilege to attend this session because it is very easy to digest. Because when we take the long workshops, so we get tired and we get carried away. So it is very good to digest. Yeah, thank you so much. It was a nice opportunity.
Thank you, Fatima, for the nice words. Thank you.
You're welcome.
Thank you, Prof. Actually, it was a great session, and we'd like to convey thanks to Dr. Mahdi Hassan, our brother, And I am also very happy that some of my classmates, they have also joined because of me. And really, it is a very lovely session and very easy and very understandable session, Prof. Thank you so much.
Very much.
Thank you.
Thank you. Thank you for the nice word. Okay. Thank you. Maybe I will give to Dr. Mahadi Hassan to close the session, please.
Okay,
Doctor?
thank you very much. We'd love to see you again. Hopefully, we'd like to organize another session. And that one will be either AMOS or maybe PLS. So let me think. Okay, thanks once again. Thanks, Dr. Amsal, for your valuable time. Assalamualaikum. And good night.
Okay.
Walaikum salam.